So I start the lesson off asking the students to work out the probability that in a throw of 3 coins they get 3 heads. So by listing all the outcomes we can see the probability is 1/8. This of course could have been worked out using the independent law, probability of getting a head 3 times the probability of a head times the probability of a head times the probability of a head would be a half cubed, which is 1/8. So I now point out to the students that if the experiment was repeated 80 times, then we would expect this to occur on 10 occasions. I then said to the students, well, if it occurred on 40 times, how many times would we expect it to occur? And obviously they've half the answer to say 5. Then I said, how many times would we expect it to happen in 8 occasions? And they've said 1. And then I said, well, what would you expect it to occur in 1 occasion? And they come to the conclusion the expected score would be 1/8. Yeah, I'm done if you want to come in.
Can I just get a maths book?
Yeah. Just doing your lesson. Have I got you tomorrow?
Sir, did you get my email? About the chapter 4?
Oh, yeah, I emailed you back. So is it chapter 4, S1?
Yeah.
Yeah, I'll do it. It's been a few minutes, okay. Because I tell you what was... Oh, yeah, I'll do it. It now makes sense. So we then looked at how you work out the mean or the expected score from a probability distribution. And in this particular case, the expected number of heads when 3 are thrown in any one trial is 1.5. And I've linked this to the work on calculating the mean from a frequency distribution and showing them it's not necessary to divide by the sum of the probabilities because they always come to 1. And now I showed a graphical representation of this particular distribution, pointing out that it's symmetrical, and in the case of symmetrical distributions, the mean will be smack bang in the middle at 1.5. Right, so for question 4, I know that if it's a probability distribution, then all the probabilities should come to 1. So I've got 1/3 plus 1/3 plus k plus a quarter equals 1. Now a third is 4/12. So we've got 4/12 plus 4/12 plus a third, so a quarter rather, is 3/12 plus k equals 1. So you should be able to see quite clearly that k will equal 1/12. That's just a few seconds then to get 2 marks off and running on that question. So question 5 then, so we've got probability distribution. X can be 1, 2, 3 or 4. We've got a little formula that generates the probabilities, and it should be fairly easy to see where these answers come from. When x is 1, the probability will be 1 times k, which is k. And then when x is 2, it will be 2 times x, which is 2k. So we get 3k and 4k in the same way. Now all the probabilities, if I add them together, then I've got 1k, 2k, 3k and 4k. That comes to 10k. And we should know that the sum of px equals 1. So we've got 10k then equaling 1. So k is 0.1. Okay, so on to question 6. So question 6, we've got a formula again that generates the probabilities. Probably that x equals x minus 1 over 10. So x can take values 1 to 5. Our formula will generate, the probability of x being 1 will be 0. That can't happen. 1 take 1 is 0. Then it will 2 take 1, which will be 1/10. And then we're going to get 2/10, 3/10 and 4/10. So I've created the probability distribution, but it's worth checking that the probabilities add up to 1. 1, 2, 3 and 4 comes to 10. 10/10 are 1, so we know we're correct there. So now we're looking at the meaning of, we're looking at the probability of being between 1.5 and 5.5. Although that appears to imply a continuous scale, it doesn't. It simply says what's the probability between these two values. And the only scores that are between those two values are x equals 2, 3, 4, and 5. So the meaning then of the probability that x is between 1.5 and 5.3 is the probabilities of 2, 3, 4, and 5 occurring. And again, this is further work on the same thing. Alright, so f of x then, the meaning of f of x, commutative distribution, means the probability that we're less than or equal to that value. So f of 4, for example, would be the probability that x is less than or equal to 4, as opposed to p4, which means the probability that x is equal to 4 only. So here I've written out the distribution x, probability of x, and then f of x. And we note that f of 3 will always come to 1 if, where 3 in this particular case is the highest value. So f of our highest possible value will always equal 1. And this is a useful thing in a difficult question later on. So I'll now introduce the students to the fourth column, x squared px, as part of our work on calculating the variance. I point out the variance formula is e of x squared minus e of x all squared. And I also point out that I've just shown them how to work out e of x squared. And if we drop the numbers into the formulas, then we get 5/9 for our particular distribution we've been looking at. So e of x squared was 6, that's from the previous work. The mean squared was 14 over 6, 2 1/3, and we have to square that. And when we take that away from 6, we get 5/9. So here's a sort of halfway review. Sum of probabilities of x equals 1. The mean or expected value of x is found by doing the sum of x, p of x. The variance of x is e of x squared minus the mean squared. The meaning of f of x is that the probability of x is less than a particular value of x. And the probability of x itself is probably that x takes a specific value of x. So I point out here that, the meaning of f of 4 minus f of 3. Now f of 4 means all probabilities up to including 4. So let's say we can have probability of 1, 2, 3, and 4. And the meaning of f of 3 would be the probabilities of 1, 2, and 3. And the difference would leave p of 4. Right, so with this question then, we'll write out the distribution and find the value of k to start with. So for 1, 3, and 5, it's simply kx, which gives us k, 3k, and 5k against those numbers, using the formula. Then it is a different formula for the even numbers. So it's going to be 2 minus 1k, which will give me k for 2. For 4, it will be 4 minus 1, which is 3, it will give me 3k. And for 6, it will be 6 minus 1, giving me 5k. So altogether then we've got 10k, 6k, and 2k, which is 18k. Now the probabilities must come to 1, so k then equals 1/18. And you'll see now that I've replaced k with 1/18 and written the probabilities of x in blue. So we can now answer the questions fairly easily. Alright, so for part C, the probability that I am less than 5, but greater than or equal to 2, means I can include 4 to 2. That means I add 1, 3, 3, and 1, 3, 1, 3, and 3. That's 7/18. Right, f of 4 will be the probability that I'm f of 4 is the probability that I'm less than or equal to 4. Okay, so this is going to allow me to be, we'll do this in orange so you can see which ones I'm picking out. So I can be 3/18, 3/18, 1/18, 1/18, and that adds up to 8/18. And f of 1.6 means I've got to be below 1.6. The only value below 1.6 is 1, and the probability of 1 is 1/18. So that's that question done. So we've been given the cumulative distribution function that enables us to work out the cumulative distribution probabilities. So I'm going to start off by writing down the values of x and then the values of f of x. Now the trick to getting k, which is quite different from how you found it before, is to take the fact that f of your last number, f of 3, is going to equal 1. Because f of 3 is going to include 3, 2 and 1. That's going to be all probabilities. So, and this is quite simple to solve. You've got 3 plus k squared all over 16 equals 1. So we need the top to be 16, and we can make the top 16 if we make k equal to 1. So our cumulative probabilities then will be 1 for 3, then we've got 2 plus 1 squared to be 9 sixteenths. Alright, that's 3 squared is 9, and then it will be 4 sixteenths for 1. Now for 0 it was 0 anyway. So that's our f of x distribution. 0, 4 ninths, sorry 4 sixteenths, 9 sixteenths and 1. So I've written this out. All we need to do now is subtract. So 1 take 9 sixteenths is 5 sixteenths for the probability of 3. 9 sixteenths take 4 sixteenths is 5 sixteenths again. And 4 sixteenths take 0 is 4 sixteenths. There's something not quite right about, yeah, my error is on my first probability. 1 subtract 9 sixteenths will be 7 sixteenths. So I'll just get the rubber. You can't really change that, I'll just write over it then. So we have 7 sixteenths, 5 sixteenths and 4 sixteenths all coming to 1, and that's that problem completed.